So finally, working with the modulus function with a minus sign in between, we have already looked at the standard algebra kind of approach, but now I want to look at a shortcut, a sweet, a very elegant method. So the method anybody can understand, but I would also be very curious about the logic behind the method. But for now, I will start with the shortcut or just dive into the problem solving, and then maybe we can do a later exploration of more basics in terms of how the method was discovered or derived, right? So plot the numbers on the number line. That's been a very common step throughout the process. So 3, because at 3 this will become 0, 5 because at 5 this will become 0. We are looking at a mod function. So what do I know? And I'm looking at a mod of x minus 3. So a normal mod would have been like this, and a mod of x minus 3 would shift 3 points to the right, something like that, right? That means when I think of my proper number line, the mod function is coming down to this point and then going upwards, right? I'm talking about this function only. Similarly, for a minute, forget the minus sign, and this function is coming down to the 5 point and then going up. So I'm not capturing the whole diagram, I'm only working on the shortcut right now. So with those thoughts in mind, that why am I thinking of 3 and 5, go for either of the points, say 5, and find the value of this function. This is a function of x, right? Find the value of f5. What does that mean? Put 5 everywhere and calculate what will this come out as. So I put 5 here, I will get a 2. I put 5 here, I will get a 0. 2 minus 0 will give me a 2. So just theoretically somewhere, let me plot that point, that this point is 5 comma 2. 5 in the x domain, 2 in the y domain, right? Okay, great. Plot the other point as well. Put this here, this will become 0, and 3 minus 5 will give you a minus 2, but a mod of that will give you a 2, but outside there is a minus. So overall you will get minus 2. So at this point here somewhere, and this location is 3 comma minus 2. So what am I doing? I'm finding the value of the function at the extreme points, right? At the border points. And now I will reveal the shortcut that I look at this expression and I can tell you, and we'll find out so in a minute as well. Let me write the coordinates here. This point was 5 comma 2. I'm saying beyond this point, the value of the function is going to remain the same. That means, say if you go to x is equal to 7 and you put 7 here, the output will still be 2. Right now I'm just showing the shortcut in action. I'm sure some of you may know the logic or may be able to guess, but most of you may not know. But I'm saying, okay, this is what is going to happen. I haven't solved anything. I just looked at the expression and I know this is what is the future of the function is going to be, right? How do I know that? I'll come to in a second, right? So I notice, and you can check it for yourself. 7 minus 3 is going to give you a 4. 7 minus 5 is going to give you a 2. A 4 minus 2 will give you a 2. Put x is equal to 8 in the story, or 9 or 10. Do check for yourself. 10 minus 3 is going to give you a 7. 10 minus 5 is going to give you a 5. 7 minus 5 is going to give you a 2. So no matter how far ahead you go, the value of the function will remain 2, right? So this point, for example, is x is equal to 7 and y is equal to 2. Later point will be x is equal to 20 and y will still be equal to 2. Let's think of the other direction. I am guessing just by looking at the equation that even in the other direction the same story will continue. This value minus 2 will remain constant. Put 0 in the story. 0 minus 3 gives me a 3. 0 minus 5 gives me a 0 minus 3 gives me a minus 3, but there is a mod, so it gives me a 3. 0 minus 5 gives me a minus 5, there is a mod, gives me a 5. 3 minus 5 gives me a minus 2. So even here this story will continue and the value of y would remain minus 2 only. Let me throw in a couple of questions. We'll worry about the logic in a second. Let me throw in a couple of questions. What is the maximum value of this function? The maximum value is 2, because after 2 it is logged into 2. It never goes higher than 2. What is the minimum value? It is going to be minus 2. It is never going lower than minus 2. That is visible to me. So now the question would be, what did I observe? How could I say that this value will remain constant? And the observation was here. What is the slope here? This is 1x and this is also 1x, right? So the slope for this part was equal to 1. The slope for this part was also equal to 1. So as a shortcut I looked at 1 minus 1, the slope becomes 0. A slope of 0 means a flat line, and the same thing here, a slope of 0 means a flat line. So this was I'm sure as of now it is not making sense, but I will still not go into why this is happening. I'm just saying look at what I'm doing. First of all, I'm plotting the extreme points, what is the value of the function, and knowing this function, slope was 1, slope was 1, there is a subtraction, slope 1 minus slope 1, this is a general abstraction. The overall slope is 0, that means the line is going to be flat. Why and how we'll look in a second. So changing an example will definitely help us clarify the idea, and I'm sure right now you've seen the method, but the idea might not be very clear, but I hope the basic steps of the process are getting in place. That my number one step, easiest step, is just draw the line. Anyone can do that, right? The next task is to find locations of x where this is 0 and this is 0. This is very easy. This will be 0 at x is equal to 3. Think about this. If you put x is equal to 1, 2 1s are 2, 2 minus 2 will give you a 0. So here x is going to be 1. What is the next task? Put 3 in the function. That means this is a function. Remind yourself of fx also. This is equal to y, however you want to look at it. And you're thinking of finding the value of function of 3. Put it here. 2 3s are 6 minus 2 will give you a 4. 3 minus 3 will give you a 0. So 4 minus 0, overall value 4. Theoretically just plot the point on the graph or generally on a piece of paper, and this location is going to be 3, 4. What is 3? The coordinate of x. What is 4? The value of y, right, that you have calculated. And now once again, this is where the shortcut comes in. I look at the slope of the story. Here the slope is 2, here the slope is 1. Slope is equal to 2, slope is equal to 1. You don't have to write this down, this can be done orally. And there is a subtraction sign, right? So I'm just giving a layman's very superficial just how to use the formula. Again, no theory has been given so far, right? Slope of 2 minus 1, overall slope is going to be 1. Beyond this point, right? So beyond this point, the graph will behave in such a way, and the slope of this new graph is going to be 1. What does that mean? It means if you change x by 1 unit, say if you put x is equal to 4, what do you think the value of y is going to be? The value of y is going to be 5. Why? Because x has changed by 1, y will also change by 1. Just to be doubly sure, put 4 here. 2 4s are 8 minus 2, 6. 4 minus 3, 1. And 6 minus 1 will give you a 5. So the next point in the story, if you notice, is 4, 5. The value of x is 4 and the value of y is 5. So, and again, if I want to figure out that the overall function required to be 12, so let's stay with the story. X is 3 because we figured that point out already, and y was equal to 4. And now I want y equal to 12. So can I travel from 4 to 12? Yes, there is a plus 8. What is the slope of 1? Tell me that x also should change by plus 8 only. So therefore x will be 11. Put 11 in the story and check for yourself whether it's working or not, right? So what is the summary of the shortcut, or what is it that we're talking about? Beyond the root points, I can predict the slope by just observing these 2 points, the coefficient of x. This also doesn't matter. This will matter for the 0 points, where are the roots as such. But beyond those points, that means if I make a final graph of this, now we know how to make a graph. Put the value of 0, 1, 2, 3 as x, and then figure out the values of y, right? So if I make a graph of fx, it will behave so beyond this point. Let's observe the other side. If I put x is equal to 1, this becomes 0. And if I put 1 here, 1 minus 3 gives me a minus 2. Mod of that gives me a 2 and a minus outside. So the overall point will be 1 comma minus 2. And again, because I know the underlying mechanism, or let's say the clear maths below whatever is happening, I know beyond this point, again the slope is going to be 1, but in this direction, right? Like if you go from left to right, the slope is going to be 1. So again, no need to memorize right now, just see what the first just see what the game is. Again, check for yourself. If I go from x is equal to 1 to x is equal to 0, Put 0 here. 2 zeros are 0. 0 minus 2 will give you a minus 2, mod of that will be a 2. Put a 0 here. 0 minus 3, minus 3, mod of that 3. 2 minus 3, I will get a minus 1. So I was at a minus 2 and now I'm going to a 0 comma minus 1. So it is changing by 1. And again, I want to go to 12. So play the same game all over again. Start with this point. X was equal to 1. You want the new value of x. Y was equal to minus 2. The new value of y is given as 12. So minus 2 to 12, there is a distance of 14. So 1 also should travel by 14. Right, but this is where you have to be careful. 14 in which direction? Obviously not in this direction. We use common sense and observation. 14 in this direction. So 14 from 1. So 14 points from 1 to the left of 1 is going to give you x is equal to minus 13. Check again. 2 minus 13 minus 26. Minus 26 minus 2 minus 28. Mod of that is going to give me a 28. Right. So write that value down. Mod minus 13 minus 13 minus 16, mod of that plus 16, but a minus, so overall just a 28 minus 16, which gives me a 12. So now at least the core tools are in place. Plot it on the number line. You don't even have to draw the number line. You just have to find the value here, right? Add x is equal to 3 and add x is equal to 1, and then know that beyond this you have a slope of 1. Beyond this you have a slope of 1, or let's say beyond this you have a slope of minus 1, because as x is reducing, y is increasing. But hopefully by now we already know, just change your point of view and it's 1 only in this direction, and just be careful about the direction, right? So the key summary so far is that I can just spot the slope, get the slope of the output function beyond the points very quickly, and then use it to figure out my equation.